All right. So in this example, we're calculating the Q reaction when 4.50 grams of methane are combusted at constant pressure. And the key here is constant pressure. We know that every reaction has enthalpy or heat of reaction that makes them either exothermic or endothermic. In that sense, we can use the enthalpy of the products and enthalpy of the reactants to find the delta H of the reaction. Some things you have to know is that the heat release is proportionate to the amount of reactant consumed. So however much you start with is going to explain how much heat you get. When a reaction is run in reverse, the delta H of the reaction is equal in magnitude but opposite in sign, and the delta H depends on the state of the substance. So knowing those three simple points and understanding that at constant pressure, we can determine exactly how much heat is released for an endothermic or exothermic process, all we need to do is first make this guy bigger. First, look at how much reactant we're starting with. It says here we have 4.50 grams of methane. But the delta H for this reaction here is negative 890 kilojoules per mole. So we're trying to find it in moles and we have it in grams. So the first thing we do is convert 4.5 grams of CH4 into moles of CH4. And we know for every 1 mole, we have 16.0-ish grams. So doing the math, 4.5 divided by 16 is going to give you about 0.281 moles of CH4 of methane. Now, this reaction is basically completed for us. We don't have to do any of the hard work. It gives us the delta H right here, the enthalpy of the reaction. But that's for every 1 mole. We get a release of 890 kilojoules of energy. In this case, we have 0.281 moles. So how much energy will be released? Well, we do a very simple very simple calculation, 0.281 moles of CH4 times negative 890 kilojoules for every 1 mole. And we end up with, after a brief calculation, you realize that you're going to get a release of 250 kilojoules of energy from the 0.281 moles of CH4 you start with. And that is your final answer.